Welcome to Spring LIB.
We want to investigate the family of polynomials given by the equation f of x is equal to c times x to the fourth minus 2x squared plus 1, and we want to determine for what values of c does the curve have a minimum point or minimum points, and then we want to show that the minimum and maximum points of our function will lie on the parabola y is equal to 1 minus x squared. Right, so first thing we're going to need to do is to take the derivative, because we will need to know that to find our minimum values. All right, so we get f prime of x is equal to, so to take the derivative of that polynomial, we're just going to use power rule for each of the terms. So we'll get 4cx cubed minus 4x. Now to find our critical points, we're going to need to set this equal to 0. And actually, let me go ahead and write that in green. So we need to set that equal to 0. And I'll solve for that off on the side here. So I can go ahead and factor an x and a 4 out. So it's going to be 4x cx squared minus 1 is equal to 0. So that's going to tell us either x is equal to 0 or cx squared minus 1 is equal to 0. And so we can just go ahead and move things around to solve for x here. So it's going to be x is equal to plus or minus the square root of 1 over c. Now, since we're dividing by c, that tells us that c has to be bigger than or equal to 0, or it has to not be 0, and since we're taking the square root, that means it needs to be strictly greater than 0. So at least right now, we know that c has to be strictly greater than 0. That is, at least if x is equal to 0 does not give us a minimum. But at least for us to get a solution for this other quadratic, c needs to be strictly greater than 0. All right, so let's go ahead and use the second derivative test to determine if these three values that we have here are minimums or maximums. So second derivative will give us 12cx squared minus 4. And again, we're going to need to set this here equal to 0, or actually, let's not even do that. Let's just go ahead and plug in x is equal to 0, and x is equal to plus or minus 1, or plus or minus the square root of 1 over c. So f double prime of 0, we'll plug it in 0, we get negative 4. Well, that's strictly less than 0, which implies the function is concave down at that point. And the second derivative test tells us this is a local max. So now this actually does kind of give us the fact that, well, possibly if we are going to have a minimum, it has to be c strictly greater than 0, since we've already determined that x is equal to 0 will always be a local max. Now let's go ahead and look at the other value. Now, this here will give the same value with the plus or the minus, since we only have x squared, and the squared gets rid of the plus and the minus essentially. So I'm just going to go ahead and plug this in and solve it once. All right, so doing that, we have 12 times c. And then if we square plus or minus 1 over the square root of c, well, that's just going to be 1 over c minus 4. Well, those c's cancel out just to give 1. So we have 12 minus 4, which is 8, which is strictly greater than 0. And so this here implies concave up at both of those values for x, or we get a local min. So we only get a local min when c is strictly greater than 0, and that local min will occur at x is equal to plus or minus 1 over the square root of c. All right. So now we know where our minimums are going to be if they exist for that family. Now we want to show that the max min of that is also on the curve y is equal to 1 minus x squared. So in other words, what this is really wanting us to show is that when we set f of x is equal to 1 minus x squared, that it intersects these two curves at x is equal to 0 and x is equal to plus or minus the square root of 1 over c. All right, so let's go ahead and plug in f of x. So that's going to be cx to the fourth minus 2x squared plus 1 is equal to 1 minus x squared. Well, we can go ahead and subtract 1 over and add x squared, and doing that will give us cx to the fourth minus x squared is equal to 0. Now let's factor out x squared. So we get x squared times cx squared minus 1 is equal to 0. And now this is going to say either x squared is equal to 0 or cx squared minus 1 is equal to 0. Well, x squared is equal to 0 only when x is equal to 0. And you might notice that this here, actually let me use a different color, use green. So you might notice that this here is exactly what we solved for up here when we were looking for our critical values. So this also gives the solution x is equal to plus or minus 1 over c square root. So we get that both of our critical points will also have the same output for our class of functions or our family of functions, as well as 1 minus x squared. So all the max and mins will lie on that parabola.